So, let's talk about thin layer chromatography, which is also known as TLC. It's a very simple technique for doing basic sample analysis, and it's one of the most commonly used in a research laboratory. Imagine you're in the lab one day, and you have a flask with a mixture of compounds in it. It could be an ongoing reaction, a flask that the label has come off, or a sample that you need to analyse. With it being a mixture, you'd probably like to know a couple of basic things about it. How many compounds are in the mixture, and what are those compounds? TLC can help you find out. TLC separates the mixture into spots of different compounds, so it's easy to see how many are in the mixture. So here, 3 spots equals 3 compounds. As with other types of chromatography, such as paper or gas, TLC separates the compounds as the mixture is carried over a stationary phase by a mobile phase. A TLC plate consists of the stationary phase, normally silica or alumina, on a non-reactive support, normally aluminium or glass, sometimes plastic. The mobile phase is the developing solvent, also known as the eluting solvent. As the developing solvent travels up the plate, the compounds are caught in a tug of war between sticking to the surface of the stationary phase, known as adsorbing, or dissolving into the mobile phase. As different compounds prefer dissolving or adsorbing to different degrees, they travel different distances up the plate. Compounds that dissolve well will generally stay in solution, travelling up the plate with the mobile phase. As a result, they will end up close to the maximum height the solvent reaches, the solvent front. Compounds which adsorb strongly onto the stationary phase will not be carried very far by the solvent, and as a result will not move far from the baseline. Let's return to your mystery mixture. Having established how many compounds are in it, you'd probably like to get a sense of what they are, and TLC can help here too, using retention factors. A retention factor, often abbreviated to RF, is the ratio between the distance the compound travels up the plate compared to the distance the solvent travels. Thus, comparing the RF of a compound in your mixture to a published table of values can let you identify the compound. Alternatively, running a pure sample of compound you suspect may be in the mixture alongside the mixture means that you can make a direct comparison.